Hello mathematicians, this is lesson 2 in our solving radical equations unit. After this lesson, you will be able to solve and check radical equations that have operations on the outside of the radical. All right, so what we are going to look at for our vocab, it's not really vocab, but kind of a checklist of what we need to do to solve. So first you need to isolate the radical. So just like we said in the objective, we're going to be solving radical equations that have operations outside of the radical. So our first step is to isolate that. Then we square both sides, then we solve, and then we check. All right, so our first one, we have the square root of the quantity of r plus 10 plus 4 equals 7. So what's different about this lesson than our last lesson is that our radical was already isolated in lesson 1. But if you see here, and sometimes I encourage you to just make a vertical line down the radical and see that this plus 4 is on the outside. So that is the first thing that we need to work on. So we're going to use inverse operations because anytime we move something from one side of the equal sign to the other, we have to use the opposite operation. So since that is plus 4, we are going to subtract 4 from both sides. We are going to bring that radical down as it is. We haven't done anything to it yet. Equals, and then 7 minus 4 would be 3. Now that you see there's nothing over here, there's nothing behind it, the radical is isolated, so the opposite of square root is squaring. But if I square this side, I must square the right side as well. So since that's inverse, it goes away, leaving us with r plus 10 equals, and then remember that exponents are repetitive multiplication of the base. So 3 times 3, not 3 times 2. 3 times 3 is 9. And next we solve. So our goal is to get r by itself. So we need to move this 10. The opposite of plus 10 would be minus 10. Bring that r down, and 9 minus 10 would be negative 1. So that's what we think our answer is. We can always check it. So when we solve, we work from the outside in, but when we simplify or check, we work from the inside out. So the first thing we need to do is simplify that. Negative 1 plus 10 would be 9. Still have that plus 4 equals 7. The square root of 9 is 3. Plus 4 equals 7, and then 3 plus 4 is 7, which equals 7. So because that came out to be equal, we know that this is the correct answer. All right, let's take a look at this next one. So inside of our radical, we have r divided by 8. But on the outside, we have 4 over here. And notice there's no plus sign, no minus, and no fraction / division, right? So that leaves only one operation left. The one operation that we can get away with not writing would be multiplication. So this is multiply. So the opposite of multiply would be divide, right? So our goal is to isolate the variable first. So we've got to get rid of this 4. This 4 is being multiplied to the square root of 8, r divided by 8. So the inverse of that would be divide. So we're going to divide by 4 on both sides, leaving us with the square root of r divided by 8, and 16 divided by 4 is 4. Now that our variable is isolated, or sorry, not variable, our radical is isolated, the inverse operation of square root is squaring. So if I square the left, I must square the right. That goes away, leaving me with r divided by 8 equals 4 squared would be, not 4, 16. Our final step would be to isolate r, get r by itself. So right now r is being divided by 8, so the opposite would be multiply. And 16 times 8, 8 times 6 is 48. 8 times 1 is 8, plus 4, 8, 9, 10, 11, 12, 128. Let's check that first. So 128. 8 goes into 128. Let's see, probably 16 times, since 8 times 16 is 128, so 16. And the square root of 16 is 4. And 4 times 4 is 16. So we do have the correct answer. All right, let's take a look at the next example. So same deal. We have this -7 there. Notice that this is not between them, so it's not 7 minus. This is -7 times the radical. So the opposite of that would be divide by -7, leaving us with the square root of 8n plus 9 equals, and -49 divided by -7 would be a +7. Our radical is isolated, so the inverse operation of a square root is squaring. That goes away, leaving us with 8n plus 9 equals 7 times 7 is 49. And now we have a good old two-step equation. Subtract 9 from both sides. 49 minus 9 is 40. Divide by 8, and n equals 5. Let's check it. 8 times 5 is 40. 40 plus 9 is 49. And the square root of 49 is 7. And -7 times 7 is -49. So since that is correct, we have the right answer. All right, let's take a look at this last one. Where does this radical end? This radical ends right there. So notice that this +3 is on the outside. That is the first thing we need to do to isolate our radical. The opposite of +3 is -3. 11 minus 3 would be 8. We still have the square root of -1 minus 13b. And now that the radical is isolated, now that the radical is isolated, the inverse operation of a square root would be to square. 8 times 8 is 64. A square root and a square are inverse operations, leaving us with -1 minus 13b. And now it's a good old two-step equation. Our goal is to isolate this 13, so we got to move this -1 by adding 1 to both sides. We get 65 equals -13b. Divide by -13. And I'm assuming that 13 goes into 65 5 times, but let's double check. 13 times 5, 5, 10, 15. 5 times 1 is 5, plus 1 would be 6. So yeah, 65 divided by -13 is -5. Let's check to see if we are correct. So our goal is to work from the inside out, so we still have -1. -13 times -5 would be a +65, plus 3 on the outside. -1 plus 65 would be 64, plus 3 out here. The square root of 64 is 8, and 8 plus 3 is 11. So since that is equal, that is the correct answer. When you go look for these, look for multi-step radical equations. And as always, happy mathing!